So for this example, a 8-meter ladder. So this ladder with the length of 8 rests against a vertical wall. So see the figure. If the bottom of the ladder is sliding away, so just imagine you are landing your ladder, so your ladder is sliding. So when it's sliding away from the base of the wall, so this is your wall, this is your wall. So when it's sliding away from the base of the wall at the rate of 3 meters per second, how fast is the top of the ladder moving down the wall when the bottom is 2 meters from the base? So let us define our variable that happen here. As you're landing your ladder against the wall, so the length here, the length is keep on changing. As you're sliding, so your x is extending. So your x, the length here of the x is increasing. But as you can see, if your ladder is sliding away, means the length of vertical here, which is your y. So you're going downwards. So this y is decreasing. So let us define our variable where x is the length of the bottom of the ladder from the base of the wall. Meanwhile, for the y is the distance of the top from the ladder from the base of the wall. So our first step, identify the variable, identify the constant, the variable, and the shape. The shape very obvious here. We can see this is a triangle. And as we read here, we identify our changing variable here. So the rate is 3 meters per second. So the ladder is sliding away from the base. So this one is moving away. So this will be dx dt. So as it's sliding away, this length is increasing. You can see it's getting longer. So therefore, this rate will be in positive 3 meters per second. And the question asks, what is your rate of the ladder moving down? Means we are finding the rate of dy dt. And your constant here, you can see 8 will be your constant. So for this triangle, your hypotenuse here will be constant. So only the xy here is changing. And you want to find this rate when the ladder moving down the wall when the ladder is 2 meters from the base. So you want to find this dy dt when it is x equals to 2. So that will be lastly we substitute to our chain rule. So step number 2, we identify the chain rule. So if you dy dt, it may be involving dy dx times dx dt. So as we can see here, dx dt is given. So dy dt, we know that we start with variable y ending with variable t. So the quantity y is ending with quantity t. So the quantity that link y to t is x. As we can see, we have dx dt from the questions. Then we go for question 3. Step 3. So step 3 actually is finding the equation that we want. So since dx dt already given, means we want equation y in terms of x only. So look at triangle here. What's the equation that can link x and y and this 8? So triangle, normally we can deal with Pythagoras theorem. So based on Pythagoras theorem, we know that x squared plus y squared will be your hypotenuse x squared. So x squared plus y squared will be equals to 64. So this is our equation. Equation in terms of x only, yes. So we have only x and y, but this equation is not explicit. So when we want to differentiate it, we are doing it as implicit differentiation. So we differentiate y with respect to x. So this is our objective of finding. So differentiate y with respect to x implicitly, this one 2x. So for y, we also differentiate, but this one will get implicit differentiation, dy dx, differentiate constant, we get 0. So therefore, we can get dy dx, which is equal to negative 2x over 2y, where 2 can be simplified, negative x over y. So lastly, step number 4 is we're going to substitute everything into our chain rule. So dx dy dx is negative x over y times dx dt, information from questions. So what is the constant that at the rate of dy dt? We need to substitute x equals to 2, but we notice that we still lack of information value y here. So we find the value y first. So when x equals to 2, we substitute into the original equation here. 2 squared plus y squared equals to 64. So y squared is equals to 60. So y will be positive negative 60, but this y is about length. So it will be not suitable taking length as negative. So we take it square root of 60 only. So lastly, substitute back into our chain rule. Dy dt equals to negative x, which is 2, y, which is square root of 60, and times with 3. So use our calculator to simplify this. Here we have negative 775 meter per second. So negative. When we do our conclusion for this question, the rate of the top is decreasing. As we can see, rate here is negative. Therefore, the top of the ladder is sliding down. So down already represent the situation of decreasing, sliding down the wall at the rate of 0.775 meter per second.